Hello, and welcome to this lesson on mixtures. In today's lesson, we will firstly look at the properties of mixtures and understand that they are formed when multiple substances are put together but not chemically bonded. We will also recognize that the chemical properties of the substances in a mixture are unchanged. We will then move on to explore the similarities and differences between mixtures and compounds, using some examples. This will help us to appreciate how mixtures differ fundamentally from pure compounds and how their component substances can be separated and identified based on their unchanged chemical properties. Welcome to the main part of our lesson on mixtures. Let's dive right into what makes mixtures so unique. Mixtures consist of two or more substances physically intermingled without chemical bonding. Imagine making a salad. You take lettuce, tomatoes, cucumbers, and carrots and toss them together in a bowl. Each ingredient mixes with the others, but none of them change their basic nature. This is exactly how a mixture works. The substances are combined, but they don't actually bond chemically. To visualize this concept, think of a diagram with different colored dots representing various substances in a mixture. Unlike in a compound, where these dots would connect to form new molecules, in a mixture, the dots simply intermingle without forming any new bonds. Each dot retains its color and properties, just like the components of a mixture retain their chemical properties. Recall from our previous lessons that when elements chemically bond to form compounds, they undergo a chemical reaction and create a new substance with new properties. For instance, when hydrogen and oxygen react chemically, they form water, which has properties very different from both hydrogen and oxygen. In mixtures, however, each substance keeps its own properties. For example, if you mix sand and salt, you still have sand and salt. They haven't reacted to form a new substance. Despite being physically combined, substances in mixtures maintain their inherent chemical properties. Let's take a mixture of iron filings and sulfur powder. When you mix them together, the iron is still magnetic, and the sulfur can still combust. No new substance is created and their chemical properties remain unchanged. If you bring a magnet near the mixture of iron filings and sulfur, the iron filings will be attracted to the magnet, separating from the sulfur. Similarly, sulfur can be lit on fire while the iron filings will not burn the same way. Mixtures are ubiquitous in everyday experiences. Think about the air we breathe. It is a mixture of gases, mainly nitrogen, oxygen, carbon dioxide, and a few other trace gases. Each of these gases maintains its own properties within the air mixture. Another example is soil, which contains a mix of organic material, minerals, air, and water. The components of the soil mixture can be separated and identified based on their individual properties. Alloys, such as brass, a mixture of copper and zinc, are another great example. Each metal in the alloy maintains its properties, contributing to the overall characteristics of the alloy without forming a new compound. Similarly, when you drink fruit juice, the mixture of water, sugars, vitamins, and the other substances, each retains its own properties. Let us summarize the differences between mixtures and compounds. Mixtures are combinations of two or more substances that are physically combined but are not chemically bonded, whereas compounds involve the formation of chemical bonds between atoms. In a mixture, each component retains its individual chemical properties. For instance, if you mix iron filings and sulfur powder, both iron and sulfur keep their own properties. Compounds have properties that are different from the individual elements that compose them. For instance, when iron and sulfur react chemically, they form iron sulfide, which has different properties compared to both iron and sulfur. Mixtures can be separated by physical means. For example, using a magnet can separate iron filings from sulfur powder because iron is magnetic and sulfur is not. We will further explore separation methods in the next lesson. These compounds cannot be separated into their original elements by physical means. A chemical reaction is required. For example, breaking down water, H2O, into hydrogen and oxygen gases requires a chemical reaction called electrolysis, not just a simple physical separation. In today's lesson, we delved into the nature of mixtures, understanding that they are formed when multiple substances are physically combined but not chemically bonded. We explored how, unlike compounds, the individual substances in a mixture retain their original chemical properties because no chemical reactions take place. We used everyday examples to illustrate this concept, such as mixing sand and salt, where each retains its properties, or combining iron filings and sulfur powder, where the iron remains magnetic and the sulfur combustible. We also discussed how mixtures are prevalent in our daily lives, from the air we breathe to the food we eat and materials like alloys and soil.